Hello everyone and welcome. Thank you for joining us in this session where we'll be discussing about testing the new generation of 5G transceiver. I'm Aldo Gutierrez, Product Line Manager at EXFO, responsible of the products involved in transceiver compliance testing. Joining me live today, there is an expert in the 5G testing field for going through the presentation, Jürgen Rommelsberger. Hi Jürgen.
Hi, Aldo.
So Jürgen is a senior application engineer currently working at EXFO based in Germany. He supports the European team on high-speed transmission applications with opportunities related to transport and datacom portfolio. And also we have a virtual guest speaker, Kemi Yu. So Kemi is an application engineer based in Taiwan, providing deep expertise around the bit array tester and sampling scope solutions. So, well, I think that we can start the session. In the content for this presentation, we will start by reviewing the market of 5G transceivers. Then we will present the different 5G transceivers that are available today in the market. And then we move to the different best practices for testing and validation of 5G transceivers. In the second part of this presentation, Jürgen will perform a live demo for validate a 5G transceiver. Okay, so let's start. So since 5G transceivers are the new generation of pluggables, silicon photonics is the core technology to develop those kind of new devices. So according to recent reports about silicon photonic applications, the transceiver industry will experience a quite solid growth between 2019 and 2025. The forecast provides information about the different fields where the transceivers are employed, including data center, long haul, and 5G applications. So as you can notice, in 2019, there were no 5G transceivers, but in 2025, a good chunk of the silicon-based devices will be focused on 5G transceiver applications. So this growth is based on the definition of 5G networks, which involves a massive densification, which means that more transceivers must be installed in the different 5G stations. So now let's present the different optical transceivers that we have in the 5G network. So I will start by presenting the front haul devices. So as you can notice in this table, the 5G transceivers for front haul are a combination of different form factors and different rates going from 10 gig up to 100 gig. So as you can notice, NRC is the predominant modulation and the reach is not that long. It's between 300 meters and 10 kilometers. So if we move to the mid-haul transceivers, in this case, once again, we have a mix of different samples going from 10 gig up to 100 gig. It is expected that in this part of the network, the rates will go up once the 5G is massively deployed. So for instance, we have some SFP Plus for 10 gig. We have SFP28 for 25 gig. Could be bidirectional or not. Also now we have some 50 gig in QSFP28 form factor, but also in SFP56. And once again, NRC is the predominant modulation, but we start to see some PAM4 based devices for 50 gig. The reach in this case is from 10 kilometers up to 80 kilometers. And compared to the front haul, now we have longer reaches, which means that the power consumption is also higher than the front haul. Finally, if we go to the back haul, which are the transceivers spaced between the CU and the aggregation layer, we start to see higher rates. So going from 100 gig up to 400 gig, we have different modulation. We have some PAM4 based transceivers, but we also start to see some coherent transceivers based on 16-QAM modulation. So coherent is one of the new wave in the transceivers field, and we start to see those kind of transceivers in QSFP-DD ZR form factor, but also in CFP2 DCO as well. So this is the current state of the 5G transceivers. So now let's talk about how to qualify those kind of devices. So what transceiver vendors do in their facilities is basically to run two kind of different tests. One is the parametric test, which are performed during the production, and it's basically to evaluate the quality of the internal optical components. So there they measure the average power, they measure as well the wavelength reference and the side mode suppression ratio test as well. And then there is another kind of test, which is the functional one at the end of the production process, and it's mainly for quality control purposes. To run this kind of test, they typically use a bit error rate tester and an optical sampling scope. So in EXFO, we are proud to announce the unique end-to-end transceiver testing solution. As you can see here, the device under is the transceiver is the device under test, and for the electrical part of the DUT, we have different solution. For the bit error rate tester, we have a couple of electrical ones, like the MA4000 and the BA4000. But also we have some protocol bit error rate testers, such as the FTVX 88460, powered up with the iOptics smart application. So for the optical signal of transceiver, EXFO has a very wide expertise, providing different elements such as optical switches, DCA or sampling scope, like the EA4000. We have VOAs and power meters, and we have different solutions for the optical spectrum analyzers. As I said before, one of the key elements in the end-to-end transceiver testing solution is the electrical bit error rate tester, the VA4000. So this is a family of products with different models with capabilities going from 100 gig up to 800 gig, and power up with FEC capabilities and supporting NRC and PAM4 signals. So to go for more details, I propose to see the video that was prepared by Camille. So let's check it out.
Hello and welcome to this demo of our high-speed testing solution. I'm Kami, Application Engineer at EXFO. Today, we would like to highlight the advantage of BA4000. 800G bit error rate tester. BA4000 has very unique design on the high-speed connector. We call it OSMPM. It can support up to 67 GHz and can guarantee our 56 gigabaud signal quality. The connector comes with 1x8 type, easy to plug and unplug. Just 4 steps needed to complete the 32-port connection. If you are using our MCB, which is also OSMPM type, this will save more time and reduce operation error. BA4000 has excellent eye quality. The 26 gigabaud PAM4 eye width is more than 25 picosecond, very clean crossing point. The larger eye width means signal has good quality in high frequency. The 53 gigabaud also has very good quality. The PAM4 eye width is larger than 6 picosecond. This is better than what the competitor can offer. BA4000 comes with user-friendly GUI and intuitive setting from left to right and one by one. PPG support most requested PRBS pattern and also the SSPRQ. Output amplitude up to 1000 mV and 1 mV per step adjustable. Pre and post cursor supported, upper and lower eye adjustable. With reach measurements, we can show the BR by MSB and LSB. We also support BR monitor versus time that is useful for overnight and remote testing. BA4000 can show pre-FEC BR, post-FEC BR, FEC margin. This is very important information for 400G transceiver. And also, we are the first instrument to provide FEC graphic tool for analysis the cohort versus symbol error. This will help R&D to check burst error and random error easily. Another small tool is channel simulation. We can show the eye-side simulation result that measure from ED to understand if your host side has eye-side issue. We also build the quickly start guide on help menu. You can browse any setting you are looking for. It also includes the AP code API. BA4000 is unique design for 400G application. We already help more than 50 companies to find 400G transceiver design issue with our BA, especially with our FACT function, a key unique function to resolve issue. If you are looking for more detail about the FACT function, please reach out to EXFO. Thanks for your attention.
Okay, thank you, Virtual Cami, for this nice video. So let's move forward to the second key item in the end-to-end testing solution, which is the DCA, the EA4000. So the EA4000 is the fastest optical scope in the market today, acquiring up to 1 million of samples per second. We have different models. We have some single mode ones and some multi-mode models as well. And to know more details about this solution, I propose to jump to the second part of this presentation, which is the live demo performed by Jürgen. So Jürgen, the micro is yours.
Thanks a lot, Aldo. I will quickly share my screen. So let's see first the demo setup. For the live demo, we have chosen the following test setup. This consists of the BA4000 and the GU installation on an external PC. This is to provide the test signal filled with a pseudo-random binary sequence, or in short, PRBS. From the BA4000, we are the OSMP cable to the module compliance board for the SFP28. The OSMP connector guarantees a high electrical and mechanical reliability and stabilities. So users can snap the connector directly into place for a quick test setup, or screw the cables accordingly to increase the stability of the connections during longer examinations. The transceiver under test is in 25G base LR, which has a sender wavelength of around 1310 nanometers, and the distance range reaches up to 10 kilometers. As Aldo already described, this transceiver type uses the NRZ modulation. The nominal bitrate is 25.78 gigabit. This is conditional based on the phi type, and Reed-Salomon forward error correction is used. And that means without the forward error correction, and 66 block encoding is applied in the PCS sublayer, or if FEC is applied in 257 block encoding, so that the nominal bit range remains always the same. The used Reed-Salomon FEC algorithm is in KEA4. So the coding gain reaches around 5 to 5.5 dB, and this helps to improve the bit error rate and allows the PHYs to run across very lossy channels. The transmitter of our transceiver under test is then connected to the EA4000 sampling scope, or the signal can be looped back to the error detector of the BA4000 to allow a bit error rate sensitivity test. This, of course, would require a variable optical attenuator to be positioned in front of the receiver. And as Aldo already described in the setup for the end-to-end transceiver testing solution, this is then usually done with a switch included, so that no reconnection change in the adaptation is required. For building the setup, it's important to note that all optical connections were cleaned in advance and the surface were checked with a video inspection probe. As we all know, a not proper cleaned connector can have an impact on the quality of the eye. Not to forget, the trigger signal for the scope is also provided by the BA4000. Also for here, the quality of the cable is important, and the scope uses, in order to have a high quality measurement and built-in low jitter mode function. For the demo, the focused parameters to be measured are the output eye mask compliant with IEEE 802.3 BY and the extinction ratio. There are, of course, other parameters like the optical modulation amplitude, the OMA, which is the difference of the mean value as 1 and the mean value 0. And there is also in relation of OMA to the average power and the extinction ratio, which means for a high extinction ratio, the OMA value is around in the range of 2 times the averaged power. As we all know, the digital communication systems transmit binary data using 2 levels of optical power, where the higher power level represents in binary 1 and the lower power level represents in binary 0. An eye diagram, as shown on the slide here as well, is a useful tool for understanding signal impairments in the physical layer, verifying the transmitter output compliance and also revealing the amplitude and time distortion elements that can degrade the bit error rate. By taking samples of the high-speed digital signal, an eye diagram is the sum of all samples superimposing the ones and zeros and the corresponding transition measurements. And the results is then called eye. The eye mask is the boundary of the eye pattern waveform, time, and amplitude. And the value and waveforms are specified within the related communication standards. One note here, the measurement is done based on a first-order Bessel-Thomson low-pass filter, so that the frequency response provides a consistent measurement method for characterizing optical transmitters. And for the eye mask margin, we are recommending to use 1,000 waveforms or 2 million samples. The extinction ratio is the ratio between the 1 level L1 and the 0 level L0 as shown on the slide. We have to see that in most practical optical transmitter, the laser must be biased so that the L0 is in the vicinity of the laser threshold, meaning that the finite amount of optical power is emitted at the low level, and thus means L0 is larger than 0. Also for the measurement, the dark current of the receiver's photodiode, the terminal form charge carrier must be taken into account, and the compensation is usually done by a calibration. This is expressed in the formula shown here. The extinction ratio is an important parameter and included in the specification of most fiber optic transceivers. When the extinction ratio is not optimum, the transmitted power must be increased in order to maintain the same bit error rate. The increase in the transmitted power due to non-ideal values of the extinction ratio is then called power penalty. Okay, but now let's see a real measurement. For the operation on the GUI, we can easily move from left to the right, which means we first can set the center wavelengths. The optical receiver can principally support single mode and multi-mode operation. So different versions are available. So the covered wavelengths are 850, 1310, 5050 nanometer. The simple rate selection is to adapt to the corresponding transmission rate of the transceiver under test. And the trigger clock ratio can also set here and the proper value is 1 to 8. For the acquisition, so for getting all the sample points, we select 1000 waveforms. And the hardware filter setting to on, this is applied always, and this will activate the fourth order Bessel-Thomson low-pass filter to realize the required transfer function. And finally, for the mask margin measurement, we select here the mask, and for the transceiver here, we have to select the 25G LR. So to start the measurement, we first click Auto Scale function and then clicking the Run button. So I have used the repetitive acquisition so that you can get an impression how quick the sampling is done. So quick refreshing of the display, and it takes below 2 seconds to acquire all the 2 million sample points. For selecting the measurement parameters, all the selectable parameters are on the left-hand side of the waveform. And by simply clicking on that area, it will be transferred to the right-hand side, and the result is shown accordingly. The other way around, so to remove a result, is on the same way, just clicking again on the button here. So really easy adaptation to the needs on the testing results or on the to be tested parameters. So we have select here the 1 level and 0 level. The difference is shown on the eye amplitude. We find also the extinction ratio here, which we have discussed before, the average power, and also the optical modulation amplitude. The optical modulation amplitude is measured at the cross point, and the eye amplitude is measured in the middle of the eye, so at half of the bit period. The VSCP parameters, the vertical eye closure penalty, is required for the receiver stress sensitivity measurement calibration, and the test point is at or on the media-dependent interface. And here, the mask margin parameter, so it's always refreshed after the maximum of 2 million samples is acquired. So yeah, as you can see, a really fast acquisition time, and I think it's obviously that is not to the expense of the quality, and I hope you can all agree with me. It's rather the opposite, and this can be easily seen on the screen on the double trace at the beginning of the rise time, which is a typical behavior for this kind of transceivers. So reducing the testing time can make a significant difference, or in other words, the ultra fast high-speed scope can reduce the cost as the required testing time is reduced significantly. Yeah, this concludes my demo for the scope. Thanks a lot.
Okay, thank you very much, Jürgen. So, well, with the live demo, we have concluded this presentation. Probably we have time for one question.
There's one question from the audience, Aldo.
Okay, yes, go ahead, Falk, please.
From a testing perspective, what is the biggest challenge to validate a new generation of 5G transceivers?
Okay, thank you, Falk. So, yes, very interesting question because as we presented during the this session, there is a very wide variety of pluggables for 5G networks. So it includes different rates going from 10 gig up to 400 gig, and also different form factors. So it's really challenging to have a single bit error rate tester or single equipment to test all that wide variety. So the problem is really that the challenge is to have a solution that supports different rates, different form factors, and also a solution that can be adaptable for the coming MCA transceivers. So as we can see, or the experience says that every single year there are new form factors in the market. So the solution needs to be ready to support these new form factors coming. So in EXFO, we are ready to that. Our bit error rate testers covers different rates going from 10 gig up to 400 gig. And also they are future proof because we can modify the transceiver. We can test different form factors with a single solution. Okay. Well,
thank you, Aldo. Yeah.
Thank you, Falk. So, well, that's it for today's session. Thank you for attending and hope to see you soon. Take care.